Okay, so you're a member of a team and your challenge is to design a fun and safe ski track for an artificial ski resort. You were told that the initial drop is about 125 meters from the top. Your task is to design the horizontal run that starts at the bottom of the slope, and that is enough to bring the skier to a complete halt, and the speed that they obtain as they go down the slope. While slowing to rest on a horizontal, the skier cannot experience a deceleration with any more than 1/10 of an acceleration. Okay. So we know that they stop, like it's 125 meters. It's like they're coming down a 125-meter hill. Is that?
So design the horizontal that starts at the bottom of the slope. So you have to figure long enough to bring the skier to a complete halt.
We have to figure out like the distance that will get them from like this speed to 0, right?
Because what is the speed achieved by the skier at the bottom of the slope?
So we have to figure out like what speed they get here and then how much distance it would take them to get to 0, right?
Yeah.
So is that where we
use
use that K1 plus K2 or P1?
Yeah.
Okay, cool. So, and then once we find out the height, or wait, we have the height, so we'll find out the velocity with that, right? The speed?
Yeah.
Okay, cool.
So just do that K1.
Yeah, so it's going to be K1 plus P1.
Are we recording?
Yes. K2 plus P2.
Got it.
So then K1 is 1/2 mass times velocity squared plus hgm equals 1/2 velocity squared plus hgm. Okay. So now we know the height, and then we can just use a constant mass, right? You just plug in something.
Yeah, we can cancel out the masses. Cause,
Is that what you? Okay.
yeah, they're on both sides.
I usually just I can just like cancel out.
Yeah.
Oh, why didn't I? I don't know why I didn't do that earlier. I mean, I ended up canceling out. So
How did you write that out? So it's like
so it's 1/2 mass times velocity squared plus hgm. So it's like height plus gravitational acceleration. Or
velocity squared.
It's
So-
plus.
You can cancel out only the M's, correct?
And then it's
No, you can cancel out the. Can you cancel out both of the m's
and
on?
what's that right
Yeah.
there?
So I can just like.
And half mass.
So it would just be like velocity squared plus hg equals velocity squared plus hg. I'm saying g is the gravitational constant a little bit.
What is that right there?
This
Yeah, what's
is
that?
kinetic energy, hgm.
Oh, okay.
So then,
Okay,
so the velocity squared. Okay, so we have velocity squared plus the height is 125 at the beginning, right? Is it? Yeah.
125.
Oh wait, no, that's our potential energy, isn't it? The 125.
I'm confused. They don't really
Meters
give
from the
us
top. So that's
Well, they
like that's
give
like the
us-
final.
All they
no,
give us is
wait.
the
That is
height.
initial. So initial is
Well,
125.
so we'll know that the
So that'd be the
initial
initial
is
height.
125, and then the
Oh, yeah, this
the other
makes
height will be
sense.
0.
Right.
No, this makes sense, yeah.
Okay.
So and then G is 10.
But we don't know the mass either.
But you can just pick a constant mass because the mass is going to stay the same, and that's why we canceled out
Yeah,
the
you're
mass,
right.
right? Okay. So then it's just going to be b squared plus 125
Times
10 is
times 10 equals b squared plus 0 times 10. So it's just going to be b squared.
so 1250 equals V squared plus 0.
Well, you have a v squared on this side as well.
And then from here,
But 1250 doesn't equal 0.
no this.
No, I know, but once you subtract the v squared on both sides, you have 1250 equals 0, and it doesn't. Try to solve that. You can't solve it.
That we did the same thing.
No, I know, but you can't solve it from there if you do it this way. Do you know what I'm saying? Like v squared plus 1 plus 1250 can't equal v squared plus 0.
Okay, so then what did you get?
I don't know. How did you do it, Anj?
did you guys get 50?
I think I made a little mistake. So,
I mean, you can cancel out
oh, the
K,
10.
the PPE,
Yeah, so did you
Kinetic
get...
energy at the top is 0 anyway, so those are 0. You can
Oh, yeah, the V squared. So it's just going to be 1250 equals V squared, right?
half times, so like I just made x the speed, because that's what we're trying to find.
Yeah.
And then I did half x squared is equal to 125 times 10.
Yes.
And then you just calculate it from there. X would give you 50.
Why can't I do basic math?
It's just 1250 plus 125.
And then you just find the square root of 2500,
Yeah.
Is that
which is
that
50.
right?
Yeah.
No.
How did you?
It's going to be 1250 equals 1/2 V squared.
So you wouldn't multiply by 10 here.
No, because we didn't use the mass. The masses cancel out.
So this goes to.
So that gives us our speed at the bottom, right?
Yeah.
So then we have to use that speed with 0 again to figure out what the distance needs to be. Okay.
So that we use
Is that meters per...
meters per second
Second
squared.
Okay, so now we have that, and we have to do... So that's the answer to that question, is it's
50.
50 meters squared per
So
second.
what is the speed?
What is the speed at the bottom of the slope? Now we have to figure out how long the horizontal run must be. So do we do the same thing but with 50?
Like add it into the equation?
No, like do we do the same thing but with 50 as our height?
No,
Or
now
no,
we're-
because it's a speed.
We're trying to find the distance now. It's pretty much the same equation we used in the quiz we just did.
Okay.
So
Oh, yeah. So it's going to be change in distance over...
so
Wait.
average velocity is
equals
equal to
change in
change in
distance.
position over change in time.
Time. Yep, okay.
So average velocity equals.
Yeah, but we do not have a change in time, do we?
I think that we have to... Shoot.
How long must it be? So the distance.
If we... Hold on, let me think about this.
Average velocity is change in position over change in time.
Yeah, but we don't have a change in time, so that means there's something else we have to do before this is. So if our speed is 50 here, we have to figure out how we can get our speed to 0. Like how long it would take for the deceleration. So do we have to look at acceleration?
What's like
Getting our
mass and acceleration or no? Not forces. Does that factor into this?
So if it's going 50 at the bottom, now it's just figuring out how much time it will take, or how much distance it will take.
Okay. And distance
For it
is
to-
velocity. Or like so velocity is
So we need something with the change in velocity.
velocity is change
Acceleration,
in position.
right?
Acceleration?
Yeah.
So change in velocity over change in
Yeah.
time?
Yeah.
Yep.
That's what we need to look at, I think, right?
Yeah.
And then we
Again,
can find the time.
We don't have a change in time.
Yeah.
But we can...
How do we find time?
Hold on, let me think about this. It says, while slowing to the rest on the horizontal, the skier cannot experience a negative acceleration. Okay, so...
So they cannot experience a deceleration of 1 meters per second squared. Do you see that? Because of any more than 1/10.
A 1/10 of an acceleration, yeah.
How do we figure out the time though?
I'm just thinking.
What is?
Have we learned like a?
What kind
I
of?
think there was something about time, but I don't remember.
Hold on, it'll come to me. Just... I mean, we know that...
1/10. Can we just plug in?
Wait, if our speed is 50 and we traveled 125, hold on. If we went 125 meters and our speed is 50 meters per second at the bottom, can we find out how many seconds it took? Like, would it just be
No,
125?
but that's not giving us.
Is like no, I know what you're
Is there a way
saying.
to ask, like, just for clarification?
You could ask for
Just to, like,
to see if we're on the right track.
yeah.
I don't know what to ask. I'm just
I mean, just say we're
okay. I don't know if you can direct us in any way, but we're struggling. We found the speed at the bottom. We're
I don't know, like, the change in time, like, for the equations, there's no time in there. So, like, we're trying to figure out,
Well, you know,
Is there-
you're given the acceleration, right?
yeah,
Yeah, so can you use that and the speed,
that's what we were thinking.
Hold on. So,
and you know it comes to rest eventually, right?
Yes.
so if we have acceleration and we have the
So we just
You
plug
have the
it. We use
initial
this
speed
one.
and the final speed.
okay,
Can you find time from there?
because you can do
Because
initial.
initial is 125. Final would be 0.
That's not our speed, no.
Yeah.
Or is, okay, is,
125 is our
is it the formula where it's, like, the final minus the initial divided by the final minus the initial time, but we don't have the time?
Oh goodness. Wait.
Or is
okay.
it,
Okay, wait. What did he just say? So he said,
we have the initial speed and we have the final speed?
and our initial speed is not 125. That's
Yes,
how.
it
No,
is.
it's
It's 50.
125 meters. It's 50.
Yes.
We went 125
What did it
meters.
say 50?
We solved for it.
Sorry.
Or is
Okay.
it
So
the,
50.
So what was that with initial?
so there's
We
two
have the
different,
velocity and we have the acceleration.
so there's two different formulas, like, I can't remember which one's which, but there's, like, one where it's, like, there's the final speed, or final, like, velocity minus the initial velocity divided by the final time minus the initial time. But then
That's
there's-
acceleration. I think
Yeah.
the change in velocity or change
Yeah.
in time.
But then there's one where it's, like,
And then you can use
the
the
initial plus
acceleration.
final divided by 2.
That's average velocity.
Yes. Whatever.
But it has to
Oh,
do
okay.
something
Well, yeah.
with,
I think. Okay, so our acceleration right now is 1, because it cannot be more than 1/10, right?
Okay.
So the equation for acceleration is change in position over change in time, right?
No, that's velocity.
What's the
Change in acceleration is change in velocity over time.
Okay, so acceleration is change in velocity over time. So we have
Our
we
change in
have our
velocity
acceleration.
went from
We
0 to
have-
50, right?
Yeah, and we have acceleration.
Yes.
So it would just be 1 is equal to change in velocity, which is
50.
initial is 50, and 50 over change in time,
So 50?
which is
50 seconds?
is it 50 or negative 50? What's
We can't use negative.
Well, you can
Okay.
use negative. It just has to be
No negative acceleration.
no negative acceleration, deceleration of any more than 1/10 of the acceleration due to gravity.
yeah? I think this is. I mean, I don't know how else we would do it.
yeah.
Because we have the acceleration, we have the change in velocity.
Well, it's also like speed is just distance over time, right? So like if our speed is 50 at the bottom, okay, if speed is distance over time, we went 125 and 50, and our speed was 50, then we can find like how much time it took us to go down the hill, but that doesn't really, because we don't know how much time yet. Like we don't know how much time.
Answer the questions in the sequence given. So, for example, the last bullet might be easier to find that information first and then find the second bullet.
We don't know how to find that though.
Use
We're trying to
whatever
find that right
information you
now.
have to find
How long it will take for the skier to come to
whatever
rest.
last for in the
Oh yeah,
last bullet.
that's what we just got.
And then
50
after you
seconds.
found that,
Oh, that's what that one's for?
Yeah,
Oh,
because
plus
we
what
need
you had
number
earlier,
3 to be
figure out
number
what
2.
last for in the second bullet.
okay, so the answer to the third bullet point is 50 seconds.
I think so.
It's just 50.
I feel like it's not.
I know. I feel like that's too easy.
I'm just trying to think. So like, because if we went down the hill and we were going 50 meters per second down this hill, and that was our speed, and we did that in like 2 seconds or whatever, because it's like 125. I feel like it's not going to take 50 seconds from the bottom to stop. It doesn't that seem like a lot?
But it also says this skier cannot experience a deceleration.
So
of
it would
any
take a
more-
longer time
Yeah,
to stop.
that's the criteria they give us.
Because it would just have to slow down at a
Yeah.
steady rate
Yeah.
from 50.
I mean, if you think about it, 50 seconds. Actually, yeah, it is quite long.
But
I honestly think this is the only way.
I mean, I feel like, so it took us 2.5, okay, let's think about this. So it took us 2.5 seconds to go 125 in our distance. That's how we got the speed, like that's how we got the time for the hill. And then if it's 2.5 seconds, we traveled in 125 going at 50. Now we have to go from 50 to 0. Isn't there like an initial velocity minus final, which would be 0, to find out the time, change in time?
No, it's like, is it like initial?
No, he's right though.
minus
So then it would just be
final
50 minus 0 over change in time would equal
50.
50.
It's like the two minus each other over something. Do you remember that? Like initial minus final, initial minus final.
Yeah. Isn't that
50
for
minus-
average velocity?
Yeah, that's what I just.
Average velocity is velocity 1 plus velocity 2 divided by 2.
Well, there's two different
It is another
ways.
one, yeah.
The other one is this
So if it's 50 minus 0 is our,
50.
so we need to go from 50 to 0.
Yeah. I mean, then we can calculate the other one pretty easily.
Do we need to find the average velocity for this, like, stretch to find the time?
We have the average velocity.
I'm overthinking this.
No, we have the average velocity.
No, we do. So I don't know what to do.
We can. Are we okay with assuming that it's 50 seconds?
I just want to know what he said again.
We can listen to the recording.
He said he always
Oh
said
yeah, we can.
what?
Or, you know, I'm just going to ask you to explain it again. I'm sorry. We were going to go back and listen to the recording, but, okay, can you explain again the same thing that you said to us last time? So, we can find the change in time using the,
Initial speed and the final speed.
And the acceleration.
Yeah.
what if we,
You told
so
us
is
the
it 50?
acceleration.
No, we're totally acceleration.
Yeah, it's
right?
1 meter
One-
per second.
Yeah.
Okay, yeah. Okay.
So it is 50.
Yeah, it's 50.
That seems like a lot of
But it's also
time.
not a
What's the
real
lot?
problem.
I feel like 50 seconds is a lot of
It's not a
time.
lot. You're coming down
But
the
then
ski
you're,
slope
and there's no deceleration, so it's like it takes you a while.
Yeah, it takes you a while, right? Yeah.
I hate skiing. It's a terrible
Okay,
experience.
so
Okay, it's
that's
50. He definitely just told us it was 50.
so number 3 is
50 is 50. What's our unit?
Okay, very good. So you can get started with
is it meters per second?
50 seconds.
So we have 50 seconds. 50 seconds, and now we just have to figure out how long it must be. So
Change in position.
now we know it's just change in position. Or
What's
wait,
the equation for change in position over change in time? Is that average velocity? No.
that's just velocity. Change in position over change in time is just velocity.
Oh, just velocity?
The first answer, it's not squared, is it? Because you square rooted it.
No, it is squared.
It
50
is.
Meters per second squared, yeah.
That's
That's what it's in. That's
Oh,
the
that's
unit that it's in.
yeah.
Okay.
Yeah.
So how long must the horizontal run to be? So now we know that it's going to take us 50 seconds. We're at 50 here. It's going to take us 50 seconds. So now we just have to figure out how long it must be. Wouldn't it just be if our speed is 50?
It's just, I think it's 250.
That's what I was thinking. Can you
Did you get
explain that?
So using the equation, velocity is equal to change in position over change in time. We know the velocity is 50, and we calculated the change in time to be 50 as well. So that's just 50 times 50, which is 250 meters.
Yes. So then. So now we have to draw. So your task is to design the horizontal run while slowing. Okay. You're asked not just to come up with a design, but write a design report to convince your clients that your design is correct. I guess I'm writing that on the back.
Oh, do we actually have to write?
Yeah, we have to write a design report.
What the hell?
There's
Wait,
no
sorry.
way.
What the heck? How?
Well, we can just explain what we did, I guess. So
So just explain everything you did.
okay.
Stop after they come down. Stop.
So is it
I know.
50 times 50, 2,500?
Oh yeah.
So,
earlier.
oh no, you're good. But is that our answer though?
Yeah.
Okay.
Okay.
Okay, so then,
Oh my gosh, I don't wanna.
Okay, guys.
How do we explain this in words?
Do we just say like explain the formula?
This is our design. This is 125 meters. This is 250 meters.
It's actually 2,500.
yeah, because it's 50
50
times
times
50.
What is
50 times 50
The-
isn't 250, it's
2,500 what? Oh, did you say two? Okay.
2,500 meters.
yes.
I don't know why I didn't catch that.
Can we ask before we start right
Do
here?
this design.
I don't know if they're gonna tell us it's an exam. I don't know.
Design report to
This
convince.
makes sense though.
So
Like,
we
this
just have
makes
to.
sense.
We have to like. We have to sell it. So write a design report to convince your clients that your design is correct
How are we gonna
according to the calculations.
Calculations add up.
Yeah, they just do.
They just
Do we have to
do.
write like an actual written explanation, or is all our work?
Just a couple of sentences.
Oh, okay, just a couple of sentences.
Due to our calculations.
They all add up to be.
A couple sentences. How can I say all this in a couple sentences?
Okay. Let's just explain what we did. So.
I don't
Well,
even know how to fill a couple sentences.
we found that
Our design is correct.
our design is correct because of the following calculations or the following relationships between the following
Because the calculations.
because the following relationships. So we knew that we needed
Is there really a lab today?
Yes.
Which I said, yeah, there's a survey. Speed was 50 at the bottom.
When our initial was, what was our initial?
Because 50. How do we find out if speed was 50? Because of the equation. That's how you sell things. You just talk mathematically to people and they'll just be like, oh, really? Like, yep. We then to find out how long we calculated.
Wait, what was the 50 times 50? Was that just like the answers multiplied together? Or no?
100 meters.
2,500 meters.
Yeah, how
Doesn't
did you
that
get
seem like a lot?
How did you get that?
In
the
50.
velocity,
Oh wait, in 50 seconds though. That's like,
Yeah, that's
Yeah.
pretty good for. Like, you think of how fast they actually like.
Yeah.
yeah.
You know.
I mean, the equation is velocity is equal to change in position over change in time.
And what was the position?
That's what we were trying to find.
Okay.
So that's the x value, but we have the change in time, which is 50, and we have the velocity, which is 50. So to calculate change in position, we just do 50 times 50.
Our change in position.
Lexi, what'd you say after you talked about after how long, like the time and the distance and what it would do?
I just said
It
we
would.
found that our design was correct because I really just kind of talked about the calculation. So I said we found that our design was correct because of the following relationship. So we knew that we needed our speed to be 0 from whatever the speed was at the bottom of the slope. The speed was 50 at the bottom because of the equation, and I plugged in the equation. When we solved, our calculation showed 50. We then solved to find out how long in time and how long in distance it would take to go from 50 to 0. And so we calculated and got an accurate measure of 2,500 meters in 50 seconds. So I just kind of talked about I don't have enough energy in me to do a lab after this.
It doesn't say we have it on the schedule.
It doesn't?
No, it doesn't.
We're using the
Are we
change in
done?
position over